All right. What pieces do you need when you're graphing? What letters? A, H, and K. This is the warm-up. Okay. They are in order. A, H, K. Yes, 1/4 is A. Keep going. -1 is H. And 3. So what about our point of interest?
HK, opposite of H.
Opposite of HK, just like everything else that we've done. So opposite of H is 1, K is 3. Okay? And just like when we graph exponentials, there's an asymptote. Okay? You remember graphing exponentials?
Yeah.
Dig back deep into your mind. Okay? So let's just talk real quick. Okay, seriously, Pen?
That looks nice though.
Thanks. Alright, so what does an exponential graph look like?
This one.
Yeah, it's curved up, right? It's whoop, just like that, right? And there was an asymptote going through. Do you remember that? Y equals something was your asymptote? Logarithms are the inverse. The inverse of exponentials. Okay? They undo them, if you want to think of it that way. Do you remember we had to graph inverses and they reflected over a really specific line? Does that sound a little familiar? There was a nice line that they reflected over, y equals x. So logarithms look like that.
Oh.
Okay? This one's an exponential. This one's a logarithm. Yeah? What kind of exponential is this, growth or decay? Growth. So this is a growth situation. What does decay look like? It's going down. So if I reflect a decay, prepare yourself.
Whoa.
That's not right.
No.
Right. That's not right. It's got to go down. It still goes down. Now I'm two in my head.
So, what is it? Flip it the other way.
There we go. Nope. This is why I have to use Yonder Sketchpad all the time. I'm going to graph it on here, and then it's going to make sense. The key, either way, is that this one's going to have a vertical asymptote instead. This one had a horizontal asymptote, so this one's going to have a vertical asymptote. Okay? So instead of y equals, it's going to be x equals. Take a wild guess what the x value is.
3. 1.
That's an x value, right? 3. Does that make sense? So we got this guy. Okay? At x equals 1, vertical line. We've got 1, 3 is our big open circle, and it's the same as graphing exponentials. What did we do? There was an open circle, and then what did we do?
So up 1.
We went up 1, right? So instead of up, we're just going to go over. And we're only going to go to the right. We're not going to deal with ones that go to the left in this class. Okay. All right?
Wait, what?
Remember how we punched one over? In exponentials, we punched one up. Same deal. That's how you get that point. And then this guy gives you your next point. So we're looking at the number 4. So from our POI, 1, 2, 3, 4. But if it's decay, should it go up or down?
Down.
It should go down. There we go. See? It does go like that.
So beautiful.
I trust myself with this graph. I don't like it. Very confusing without points. Okay? Because how do you know whether something is growth or decay? Because this guy is less than 1, that tells you it's decay. Just like exponentials, exactly the same as exponential, your base number is what tells you if it is growth or decay. Very good question. Is that kind of okay? Do you see why I gave you a bunch of practice? You probably want to practice a couple of them. Yeah. But if you do a couple of them, you're going to pick it up. You'll be fine. That was me counting over 4. Alright. Let's flip it around. Let's do one where I give you the graph. Alright. So we've got to know AHK, we got to know POI, and we got to know our asymptote. Alright?
So the thing is at 2.
The asymptote is at 2.
And then,
Which means which of these is 2?
K.
If it's an
I'm at
X.
H.
So if this is 2, then this guy is a negative 2. Good. Okay? If you go to the right one, where do you see a nice point? If you go to the right one, where does this hit? Where's the nice point? At 2.
Why did you just do that?
In your mind.
I don't know why I thought we was in class.
Because you were hopeful.
How did you just do that?
Okay.
Why did you just do that?
So, we always look for, remember how we always punch one through? So it's going to be a nice point where it hits, right? So we're just looking at 1 over where is the nice point that gets punched out. Okay? And then back 1 is our POI. Okay? And then we got to go up 1. Where's our nice point if I go up 1 from this?
Wait, did you change the K?
That's 2. Because the POI. Mm-hmm.
And the A is 2, 1.
Well, where is the next nice point if I go from here, if I go up 1?
You go what?
If I go up 1, where's the nice point?
What do you mean?
Where's the next place that this curve hits nicely? Here.
Right there. 3, 5, something.
Right? So how far away are we from this guy? 1, 2, 3. And is it growth or decay? Growth. So that guy is a 3. If it was decay, it would be 1/3. It would be 1/3.
Oh, so what you got?
The POI.
Ow, ow, ow.
Okay? I know you haven't seen it in a while.
Mm-hmm.
Pulling it out of the back of your brain. We're going to do a couple practice problems and you'll feel better, I promise. Okay? Promise. So, log base 3 of x minus 2 plus 2. That is your function. I don't want you stressing too much about this. We're going to practice a couple and I promise it will be better. You'll be okay. I promise.